So good morning, everybody. We are going to be running through trap processing with opEvents. Handling SNMP traps using opEvents is the subtitle. It's January 2023, so Happy New Year for everybody. And we've just got three main topics today on our agenda. We're going to talk about event management and opEvents because what opEvents is and why it exists and what it does is very, very important as to why we want to do something with traps. And then I've written a little section called A Day in the Life of an SNMP Trap. We can probably embellish that as time goes on, but I just wanted to show what happens to a trap as it goes through opEvents because it's very important as it progresses through, how that works. And we're going to, show how to add new SNMP traps. And there's some complementary documentation to this presentation, which is on our wiki page. So I've included, wherever I've found a good document, I've included that as more information at the bottom of the page. I'll be sending out these slides to anyone who would like them after the training. So first topic, events and event management and opEvents. So what is the goal of event management? This is the slide that I wrote. I'll show you an interesting slide in a second. But what is the goal of event management? So, in my words, it's to reduce noise and identify business impacting incidents, ideally before there is an impact, at a minimum to speed up the time taken to identify the cause of an incident, and therefore be able to correct it. An effective event management process is one of continuous improvement to identify the important events and take automated actions, and the unimportant events and remove the noise. So, we're part of this. It's a really important principle of event management is continuous improvement. So when there's an outage, we would want to go and look at the system and understand why there was an outage, what happened, what caused the outage, what was the problem, did we see any particular events that showed that there was an issue. So if it was a server that went down or a network congestion problem, whatever it might be, we want to go and look for any telltale events that might give us forewarning of this problem, and therefore be proactive, or the events that happen when it breaks so that we can quickly identify the incident has happened and fix it. Ultimately, the goal is that, if, for example, we're receiving 1 million logs a day, raw logs from all of our systems, we would hope that less than 1,000 of those are events, and maybe 10,000, but we don't want to send 1 million events to opEvents. You can, but the idea is that an event, there's a log, then there's an event, and then there's an incident, right? So we want to have that progression and reduction. And of course, incidents would be, you could deal with them in an opEvents primary instance, or you could send them up to ServiceNow, for example. But the things appearing in front of your NOC, you want to reduce that to the minimum number of things that a human needs to do something about, right? So where you can, might want to automate things and take action automatically, which could be any number of things. But then if you can't do something or you need a human to see what's going on, then you send it through as an incident. That's the overall goal. And then I thought I'd ask ChatGPT, the OpenAI chatbot, what was the goal of ITIL event management? And this is what it came back with. And I'll leave that on the screen. But the second phrase I thought was very, very, very good. So this is an AI generating this response. I thought that was interesting. So the goal of ITIL event management is to provide a proactive and efficient approach to managing IT infrastructure and services, reducing the risk of incidents and improving overall service quality. I mean, a bit of a textbook answer, but that's okay. I read textbooks. So it's actually got two. It was interesting. What I thought was interesting, it had two answers in there. It had the goal of ITIL event management, and then I put a second one, the goal of ITIL event management. So it was sort of, must have got itself a bit confused, but that's okay. So, after its scraping of the entire internet, this is what I thought the second one was the, more to the point thing that it came up with. So then I thought I'd also ask ChatGPT, what is event management? And it came back with this, and this was a pretty good textbook response. The ITIL v4 monitoring and event management process is part of the ITIL service operations stage. It involves continuous improving, right? And so on. I won't read all this out to people. The key things are event detection, event logging, event correlation and analysis, event escalation, and event closure, right? So that's the process that you want to take an event through as defined in ITIL v4, according to the robots. So I'll refer back to ITIL event version 3. So obviously ITIL v4 is the more later version. This is the the flow chart for the event management process, and it's been an excellent reference for event management. And in fact, I think, you know, the ITIL v3 event management process was a really great step forward in how to do better monitoring and management, and it's a very, very, very powerful capability. And this was put together quite a while ago, and it's still relevant today. And that process that we take an event through, so an event being, you know, interface failed, fan failed, right? That's the actual core event, is something or other happened in the software or the operating system of the device. And now it generates an event, and then it's detected, and then it's filtered. Is it significant or not? We correlate the event if we think it's important. We trigger something to happen, and then we either do a change, a problem, an incident, an alert, an auto response, whatever. We'd ask a human for help, so forth. So these are all the things that we would want to do. And let's have a look at what we do in opEvents. So opEvents has three main blocks of functionality: filter and normalize, enrich and correlate, and then action, notification, and escalation. Right. So that's our three main points, the blocks of functionality that we have in opEvents. So if I had to relate that back to the ITIL v3 process, you can see that the filter and normalize is done in that first step. Enrich and correlate is here in the middle step, and then action, notification, escalation is our last step. So the alignment is very, very strong with that sort of standards process for how to handle events. So if you've got any questions while we're going, please feel free to ask the questions as we go. I will, at the end, I will turn off recording and let people ask questions. I know some people are shy and don't like to be recorded. I completely understand that. But if you've got questions, you can either save them up or you can pop them in the chat. I will try and keep an eye on the chat here as well on my second screen. So if you've got a question, you can just pop it in the chat. If you know, it's no problem to be shy. Okay, so let's move on to a day in the life of an SNMP trap. So this is the trap pipeline. As we take an event in, you know, and really when we start, I'd like to call them a log. So as we get something, it's just a log. It's just something happened. At that point, it arguably it is or isn't an event. We haven't decided if it's important enough. So, you know, we have a log coming in. So the real event, interface failed, fan failed, something happened, the real event happens, and then a device decides that there's a problem. So the device decides it wants to send an event called interface down, right? So that node, that Cisco router, for example, looks at its configuration, and it's really important. It looks at its configuration and determines if and where it should send the trap. Almost all operating systems include some method of filtering traps and logs at the operating system source. So you know, if you've got, you know, we've seen it with many vendors where they just, certain events happen, the software's, maybe there's a bug, or not even a bug, but it's functionally a bug because maybe they're just sending this event out all the time, even, you know, and it's pointless, right? It's no point in sending it. So there's a facility in most of these operating systems to filter the traps at the node, right? So now once the trap is actually sent, the Cisco router in this case decides to send that trap. So now it's received by the trap daemon and logged to a file. So now we have, you know, pixels in the system in a file. Now we can do something with that event. So opEvents then is monitoring that trap log, that trap file, and it loads that trap. And now we kick off the filter process. We're going to go through the details of each of these in a second. Now we kick off the filter process, which is the black and white list. And then we go to we normalize the event. Parsing rules are applied. By parsing the event, we associate the event to a node. At that point, the event is automatically enriched with all node properties. And that's a feature of opEvents. So it's you know, as soon as the event is normalized and associated to a node, you now have access to all the properties of that node while you're applying other rules to the event. Event correlation and deduplication then happens. So where you're, you know, where you're using the event correlation features and you want and you also do stateful deduplication, and all that process is happening together. As soon as we've enriched the event, now we know how all the properties of it. Now we can associate it and do all these different things with it. Now the event now has context because of the metadata associated to the node, and again, very, very important. If we've done some correlations, we may even have new events. So we may have created brand new events through correlation. We may have run plugins and generated other events, and all sorts of other things may have happened. But assuming we're just dealing with a single event, we now move on and we now take action with event actions. So now the last step is the action step to take action. So that's our pipeline. That's the process that a trap is going to go through as it goes. So let's have a drill into that in a bit more detail. So the first thing we have to do is set up the server to receive traps. We've got some documentation on our website for this, and basically you tell the trap daemon to send it through the trap handler, and now the trap handler has the data, and so the contents of a trap look like this, right? So we now have a nicely formatted trap that we can do something with in opEvents, and the trap handler, the trap handler traplog.pl is quite good. If you had a high volume of trap processing required, there are other methods that you can apply to increase the throughput of traps. So this is just going back to scaling if you needed. We've come across service provider devices that just have incredibly high volumes of SNMP traps. So you would find that be better served maybe with a different method for getting them into the file, but in principle, this is how we take an SNMP trap and get it to opEvents. At this point too, you now have a log file with a log of it. So if you decide not to process it, it's still there available for forensics or reference or whatever later on in the file. You might need to meet 7 years of compliance by archiving the file and so forth. The contents of a trap are basically, and this is our structure that we use, which is just a pretty generic structure. But there's obviously a date, there's an IP address or host name of the device that sent the trap. And then there's this little sort of UDP details string. And then there's the event name over here. This is actually the event name as decoded from the trap. So this is a Cisco MAC notification event. And then the rest of the variable content. So after that point, all of this is variable. All the trap must do is send its name, what it is, and typically it will send one other kind of data, something else it will send in a trap usually, but this is all, the rest of this content is specific to a vendor or to a trap. It is documented in the trap MIB, but that's all variable, event to event. Even sometimes product version to product version. This particular event, I don't think it's probably changed since it was introduced, but I have seen Cisco over time change traps because people ask for more fields in the trap. And that's, company's been around for a long time. That would be normal. So that's how that's our first step. We get the SNMP trap daemon to a file. Now our next step is the black and white list. So we filter the event through the black and white list. You can only have one enabled at a time. By default, the blacklist is enabled. It's a very simple feature to use. You just filter based on a regular expression string. So don't log, for example, by default we would say don't log these Cisco syslog MIB messages, and this is when you send a Cisco syslog in an SNMP trap, because you can do that. So that's one to just probably black out because you're already getting it through your syslog. But maybe you don't have syslog, you've only got SNMP traps, in which case you want to use it. But the point is you can only use a black or a white list. So and the principle there is I'm going to take anything noisy and put it in my blacklist and block it from ever coming in, or I'm only going to process events that I'm interested in. Right, so you use your whitelist and you say, this is the same rule for security, similar concept. So you're just basically saying, I know that this is a good thing, or I'm only ever going to process these 50 events or these 20 events. So they're in my whitelist, and I'm never going to process anything else. So that's not a bad way to do things if you have a very controlled environment. In most dynamic environments, I think that's probably the blacklist is a better option, where you're just going to block the things that are noisy and stop the noise from coming through. So these rules in the event list rules are processed in number order. So you not that it really matters too much, but you know we gave the number order so that there was some sort of basic structure, determinism in how the rules are applied. So anything you had more frequently should be at the top of the list, and the less frequent ones could be at the bottom. That would just be a small optimization you could make. All of this is running so fast, it's probably not that relevant these days. And if it's dropped, if it matches the regular expression, the event is dropped. Never goes through the system. Again, very important feature for where you have any kind of event, SNMP Trap, syslog, anything that you don't want to have processed in, you put it in the blacklist, and you just never have to deal with it. So normalize. The next step. Now we've gone through the blacklist. We've passed the blacklist. Now we have to parse the log. So the first step is we're going to tell opEvents which files to monitor by telling it this configuration. So what this is saying here is it's defining which log files and directories to monitor, right? So the opEvents section, it's called opEvents logs, is telling the system, the daemons, which files that we want and directories that we want to monitor. In this case, we want to monitor this one here. And it's telling the system, when you monitor this trap.log, you're going to use this parser to process that trap log. So you're telling the system, go monitor that file, and then you're telling the system, this is how I want you to handle that file, right? So you're giving it two very important bits of information. So that's in the OP common configuration. And then the next step is then the event parser rules, and we're going to go into a bit more detail on these as we go forward, but the events are processed in the number order. The rules are recursive, so that you can do an if match and then do more ifs. This creates a bit of a rule hierarchy, so you can actually structure some efficiencies into the rules. If you had large sections of parsing that you didn't want to apply to everything, you can make the rules more efficient. So if for example, you were doing something with BGP and you had a lot of logic that you wanted to apply with BGP events, but not to others, you would just put them in their own little nested block so that parsing was never executed for anything else. This is all about efficiency. Things are never a problem when you're dealing with thousands of things. When you're dealing with millions of things a day or a minute or an hour, efficiency becomes very important. So we've put the features there for you to, maximize efficiency. And that's that rule hierarchy. The if rules are a regular expression, and the annoying thing with JSON documents is that the backslashes have to be escaped. So that's not actually a valid regular expression. The true regular expression is /d+. Because it's JSON, we have to escape this backslash to display it. So we just have to put a // to represent a single backslash. So you can just do an if and then have a then, and the then can be another block, or an if is, in this particular case, we're doing a group in a regular expression, and we're capturing the date and host of the trap, right? So very simple thing that we're doing, and we're going to go through a little bit more example of what you can do with the if statements and the then statements in just a second. But that's what we're basically doing. It's saying, if I match this regular expression, I'm going to do these things. If this is true, then do this, right? If this is true, then do this. So actions that parsing can take. We have several actions that parsing can take. There's set, capture, ignore, and then in the next page, resolve and plugin. Doesn't sound like much, but it's actually quite a lot. And then there's more information there in these input sources page. But these are the things that you want to do, and we'll look at examples of how these work and what happens in a second. But basically, the then action is set. So when a regular expression matches, we set the property of the event. So in this particular case, which is straight out of the default shipping rules, if I see if_mib link down, I immediately know that it's an interface down event. The stateful property is interface. The state is set to down. and I set the priority to 3. So if this is true, then these things are also, well, these are the properties I want, or these things are also true. So I'm saying if it's a linked down event, then I know these things are facts, and I can, you know, tell the system that these are the facts that you need, right? So that's a set property, and it's very simple. You just do set property name and then the value in the brackets. So a capture is a little bit cooler, it's how you deal with variables in the event. So capture is when a regular expression includes a grouping. We capture the groupings in the variable required, which is really the event property required, right? So we're going to say if this if index, then I'm going to capture this number, which will be a /d plus as a number. I'm going to capture that as the element, right? So if this is true, then capture the variable from here. So this gives me the ability to handle any patterns and handle anything that comes through as a variable thing. We've got this great one here called ignore. So this is actually like another level of blacklist, if you like. But if you maybe had an event that you wanted to see it come into the system, but you didn't want it, or you want it in the raw logs, but you don't want it in opEvents, this would be the ignore. So this is kind of like a grey list. Maybe it's not a hard drop the event. It's just it comes into raw logs and then it goes through into the won't go as become an event. So we're going to ignore this event. So if there's an event that MS generates which says email to in it, so if we see the words email to, we ignore that event as an example. So again, you can consider this one a grey list. So there's a couple more actions that we can take, and they're not often used, or they're less often used, but still very powerful. So if you needed to resolve an IP address forwards or reverse, so for example, you were doing something with the BGP adjacency change on syslog. I couldn't find an example using SNMP Trap, so I had to refer to a syslog one. But in a BGP adjacency change, we get the neighbor IP address, so I could capture that element as the element, and then I could do a reverse lookup on that to turn the element name, the event element, into the name of the node. So if I was dealing with BGP, OSPF, other things, this would be great. I could have set up and there's some examples in the documentation of this, but I could set up my my name resolution system to include the IP addresses of my devices in the host file or in DNS in reverse. So have reverse lookup set up. You've got to remember is when you're doing name resolution in Linux, that etc hosts is always the first place. Well, depending how the server is configured, but normally by default, the first place you'll look is etc hosts. So you can just put all your IP addresses for your things that you want and then make the association to the nodes. And that means you're presenting a node name to the operator instead of an IP address. Can be useful. It's up to you guys. You've got the ability there to do reverse and forward lookups. So you can resolve an IP address to a name or a name to an IP address, whichever you might need to do. And you can do that, in the event. And then the last thing there is a plugin, and the plugins are, not to be understated. You can do a lot with the plugin, and I'm going to give you some examples in a second. You can literally do anything with the plugin. But how you invoke the plugin is you have a rule. For example, if I see this trap BGP established, that means I know that there's some extra stuff I'm going to do with this BGP established trap. So I'm going to run the plugin my BGP trap handler. So I would use a plugin where I would have things that needed special handling of some type, whatever that type might be. And we'll go and have a look at some examples in a second. So they're the actions that you can take from in the mid parser, or the trap parser, I should say. So a little more on event plugins. You can do virtually anything. They do require some development experience. If you haven't had development experience, you probably want to avoid them, to be honest. If you've done some development in any language, we've got examples, working examples, so that they're fairly straightforward. And if you needed to open a support case to get helped along, that's okay. So to get your get your base logic down. Once you've got the base logic down, then it's really easy to just tweak that logic to customize how you want it to work. So examples that from our customers out there in the field, and I didn't want to name the customers, but we have the WAN circuit example where a large US manufacturer who might make tractors uses the Parser plugins to enrich events with details about their WAN circuits. So they specifically wanted to put more enrichment into the event, and they wanted to associate all these metadata they had about their WAN circuits. So this isn't about managing nodes, it's about managing services out to their customers. So they turn everything into a WAN circuit. So of course, everything's still associated to a node, and that's fine. But they had the metadata necessary, and they just created lookup files. The way they decided to implement it, they may have changed it now, but at the time we implemented it, it was the beginning of COVID, and they put the lookup files, on disk, and they just got generated automatically. And then the plugin just grabbed the event properties coming in, looked up some data out of the event, associated to the WAN circuit, and then enriched the event with all the WAN circuit properties, and then sent that event to ServiceNow, and then gave the operations view of this WAN circuit. So they managed end customer services, and we've got a bit of a case study there somewhere on that. But in summary, that was a very powerful capability that was done with plugins. And then we have a large US agency who may use rockets. They have developed some logic in their plugins to handle long-term correlations and deduplication. So they have a way they want to process events. That's the way that's worked for them for a long time. And they have some logic and principles by how they do event management. And they wanted, which is sort of why they liked opEvents, because they could get it to do what they needed it to do. So they deal with events in a particular way, and they use the plugins. They use a lot of the default features and the GUI and everything, but they use the plugins to do some of the more advanced things that they want to do that are very specific to how they manage events, but quite interesting. So there's some more information there. There's a longer link there, input sources, Parser plugins, and then there's some examples there. There's a new feature that we added. So we sort of simplified the plugin system, but we made it backwards compatible. So you have the original way of using Parser plugins, or we have this sort of newer way with some wrapped up services that you can use. So there's some documentation there on plugins. If you needed some, we could run a several-hour session just on plugins. So if people are interested in more details about doing Parser plugins, because they're relevant for SNMP traps and they're relevant for other things, most of the time you don't need it. They are depending on how you're trying to solve a problem and what you might be trying to do. You may or may not need a plugin. So you can do an awful lot without needing a plugin. If you need them, the capability's there. So then the last thing we do in the day in the life of a trap is then take action. So now we've got an enriched event. It's got lots and lots of additional metadata. It's been associated to a node. We have all this stuff we know about the event. So now we take event actions. So event actions are a simple if this then do that rule language to make things happen. Right, and this is the core of what we want to get to in opEvents, is we want to get to the event actions, because that's the power, right? We do something with the event now. So it's important to consider, it's really important to consider that you can escalate events over time, and you can also acknowledge events in event actions. There's many other actions that we can take, and there's more information here in this shortened URL. But basically, I can look at tags, I can create tags, I can set properties, I can look at properties, I can modify properties, I can do all sorts of things in event actions. So sometimes quite powerful things in event actions. So sometimes you can actually achieve quite sophisticated logic of a problem that you're trying to solve just using event actions, right? And again, it's also hierarchical, and I haven't gone into a super amount of detail. Again, event actions could be a whole separate training session as well. But event actions are a recursive system. So you have a policy one, and then you have an if statement that's true, and then that then block is then a series of more if blocks, and then the then block can be recursed again, right? So you can have nice hierarchy, rule hierarchy. So for example, and one of the reasons we did it this way was if you're maintaining rule policies for multiple customers, you can literally have a section for each customer, and each customer wants their own policy applied and the way they want to do events. That's no problem. We just have that event section there for that customer. You might have a set of a common block of event actions that's for all customers, right? That's at the top, which is a typical sort of structure, and then you might have a specific section, and then you might at the very end of it, you might have a thing. And you've also got the ability to break while you're doing processing, you can break out of the system and you can acknowledge events. So you might find that there's some events coming through to your system, and under certain circumstances, you want to acknowledge those events automatically, which that means they never make it to the current event view. Okay, so that's event actions. That's a day in the life of an SNMP trap. That's the process that we go through. We'll jump back to that slide 11. So this is the trap pipeline. This is how we process a trap. These are the steps that it goes through. And these are the places: filtering, normalizing, specifically parsing. And then we've got the plugin if you need it, and then event actions. They're your three places that you can start to mess with or manipulate a trap, any event, but an SNMP trap as it comes through the system. I'll just pause if anyone wants to ask any questions or put anything in the chat. All good. We can move on, and I'll turn off the recording at the end if people would like to speak up. So adding new SNMP traps, how do we do that? So it's really important to get the process right. It's something that you need to think about when you're doing any event management. But in most of our environments, opEvents is processing millions of events every day. And in some environments, we just saw one the other day I think it's 8 million in 2 days. So, you know, it is there. It is doing a lot of work, and, you know, 1 million doesn't sound like much these days, but 1 million is a lot. 1 million seconds is a lot of seconds. It's a lot of days, right? So 1 million's this number that has lost value in modern society. 1 million of anything is a lot of something. 1 million grains of sand is a lot of sand. Right, so just please keep that in mind when you think efficiency is really, really important. When you're doing something 1 million times in an hour, in a minute, in a day, whatever it might be, it's a lot of things, right? So efficiency becomes very important. So the time taken to add a new SNMP trap for processing is nothing compared to the time the server will spend processing the trap for 5 years. Really, really important. If you don't need the trap in the system, just don't bring it in. Put it in the blacklist, get rid of it, never send it, right? Save the pixels, save the bytes, save the network traffic. Only send important events from the original device. And if you can, filter them from the device, never send them through, right? And then you want to get them through into the system. So the next thing it's efficiency. We talked about efficiency. Accuracy is also important, and then documentation is important. You're going to work on this system. You're going to add a new trap processing. You're going to spend a couple of days, getting some traps processed in, and now it's going to run on the server for 5 years. And so you want to make sure in a year's time when something happens, you need to investigate it, that you've got the documentation about how you added that feature, right? That might include adding this slide deck. That might include referencing the opmantic documentation. It might include any number of things that you need to do, but you do need to sort of document what it is that you're doing in the event. We do support description fields along the way, so you can actually just put some inline documentation in the parsing rules and so forth of what you're doing and why you're doing it. So, there's a lot of options for doing documentation, but, really just keep that in mind, that you set up these things for opEvents and they run for years without interruption, right? That people have the system set up and it just processes events forever, and you don't think about it. So there is a bit of time taken up front to get it right, and then it's going to run for a long time. So bit of a first step is really then set up your server to receive traps. So there's some documentation there, how to set up a server to receive traps. And then we add additional MIBs. So you would copy the MIBs from the vendor and the parent MIBs to this traps directory, and then you restart the daemon, and then you test with SNMP Translate. This entire process is documented here, so there's the details are there. And that's the relevant document right there. The full link with right down to the actual steps you have to go to. I don't know why Confluence does these great big long. I should have shortened that one. It doesn't let me do auto shortening of the what do you call these? The subtext, the subtitles of the page. So then adding rules for SNMP Trap to event parser. So these are the event parser rules, and adding rules for SNMP traps. This is an example here. it's a really good bit of a checklist of things that you have to do. So now I've got a bit of information here about developing SNMP Trap processing in opEvents. So these are some very important things that you would want to consider. You sort of need to set yourself up a bit of a development environment. Development environment is probably too strong a term. But you want an environment where you can work, that you can produce the events on demand and do what you want to be able to do. So these are the kind of steps that I would recommend. So you can optionally enable debugging. You might not need to do this. If you're doing something simple and not making many changes and it's straightforward, you probably don't need to turn on debugging, but you can. So you would just set to 1 or higher. So you go to OP Common, turn on this debugging field, set it to 5, for example, is a good number, and then you restart the daemon. And then when you're finished, you would disable the debugging. You would complete the checklist that we just talked about in the previous slide. And then now you need some way to generate the trap. Now this sounds kind of obvious, and there's dozens of ways to do this. You might go to the device itself and you might pull the cable out, or you might throw a switch, or you might do something. You might be able to go to the GUI and say generate trap. Whatever it is that you do, classic one on a Cisco router, you can go into configuration mode and go out and it'll generate a trap and a syslog and so forth. So how do you generate the event that you want as a sample, and how do you get that to happen? Once you've got a sample of the event that you know that you're going to generate, now you could do something like append it using a log, and I've got some references there. In the NMIS source, I've added a contrib directory called event testing. And there's some just trivial scripts in there that you can just append events to a file. Happy to provide, if you can't sort of get that into the shape that you need, let us know. But basically you can, that's my preferred way, is to, once I've got the event captured that I want to capture, I just whip up one of these scripts, because it doesn't take me long to write them, but you're just literally logging a sample event to a file, and then that means that the system's working normally. You're testing the system end to end. You run the little script, it generates the event. opEvents goes, oh great, I've got something to do, and it grabs the event, processes the event, and you're testing it end to end. It's a really solid way to test. And you can do it on demand, right? You can just stop, start. You can just constantly just have events going however you want them to go. So it gives you a lot of control doing that method. You can use the SNMP Trap command. This is a very good way as well. So I just gave a bit of an example here, and then we're going to have a look at some example of the parsing to parse this event in a second. So I've just made up. So we have an opmantic MIB. It's not it's a MIB really for using for arbitrary things, but the main part that's been defined in the MIB is an actual trap. So we have this sort of flexible, we have an opmantic event, which is an opEvents event, and all the properties, and you can send that forward in a trap to another system. So some customers use this for integrations with systems like TMIP, Tivoli, and so forth. Using SNMP traps as your API. It's actually, it works for certain vendors. That's how they prefer. So here's a bit of an example of sending a trap, and the syntax here is, I don't remember what this 8000 is. There has to be a number there. Oh, it's a sequence number. I think it was a sequence number out off the top of my head. And then this is the main OID, which is the MIB that you're going to use to reference this trap. And then now it's actually all the properties that you're sending. So this is saying property 4, or OID XYZ214, is a string and the word mynode. Then this MIB here is a string and is the words my SNMP trap, right? And then this is a string and so forth. So it's the OID, the name, the data type, and the value. It's quite simple. And then you just send another one, right? So that's a little tuples of, or truples of things that you're going to send. So now you would update the event parser rules with the changes that you wanted to make. So you would go to event parser rules, you'd make those changes. You should probably validate the file. It's always a good idea. Got that step. So you just do, I use JSON XS, and then I just put, and then if it's a valid file, it will parse out nicely and show you the prettified text. if it fails, you'll get an error message and it can tell you where the error is and you can go back and fix it. It's usually the last bit of the structure that you touched. Then you restart the opEvents daemon, right? And that's it. So now you're ready to run it. And so now you would send the test event, check the GUI for the results that you were expecting to see, and then you can check the opEvents log for information, debugs, etc. So that's a bit of a summary of the process for developing a trap. We'll go through some parsing examples in just a second using our made up trap that we just talked about there. But that's the basics there. And you would iterate through this process, right? So you would, what I haven't sort of talked about here is maybe some of the engineering principles under what you're trying to do, but you obviously want to have a goal for what you're trying to do. You're obviously trying to, process a new trap and get data out of it and get it in. So you want to have all of those things. So when you check the event for the GUI, you are looking for the expected result, right? And that's your test is now passing because you're seeing the result that you want to see. So that's sort of, this is a bit of a summary of that process of what you're trying to do. So let's have a look now at the parsing example. So when we run this command here to generate a trap, we end up with this trap here as a parsed process trap with the opmantic MIB and the event property, the MIB name, and we have that available to us. These are tab separated, so it hasn't showing that there's a space there, and we have the properties running here. So my SNMP Trap, an important event, and so forth. So there's all the properties that we have of the event. And so to parse that, we would say, we see here that this one's called my node. So this is the thing we're interested in here, that one there, my node. So we would just say opmantic MIB OMK equals, and then that's the pattern for a word. So /W is a word, right? I don't actually need the square brackets around it, but you could, if you're expecting, if someone was going to use dashes in their node names, then you would have to put a // for example. All right, so that's now, and I'm going to show you something interesting in a second, some tools for regular expressions and so forth. So don't be too worried about regular expressions. But so if I see that pattern, I capture the node name. That's the parsing rules. That's what they do. If this is true, then take this action. So tools for regular expressions. So I asked ChatGPT, what's a good regular expression for this text? I literally I pasted that into ChatGPT, right? ChatGPT came back with the following answer. So it said the regular expression for this test would be this. And it uses, and it explained the regular expression. So, because I've heard one or two people had mentioned to me that, ChatGPT was great for doing regular expressions. So I tried it, Dot star is actually not a great regular expression statement. It's a greedy match. It's a long story. Don't use dot star unless you have to. Dot plus is fantastic, right? So a dot is any character. Star is a greedy match, and it will do greedy matching. And there's a whole thing there about greedy matching and non-matching. Please trust me. Dot plus is a great result and is non-greedy. So when you're trying to do extract variables from the middle of a string, dot plus is a better option. So I went to the other great tool is regex 101. So you could go to ChatGPT, feed it the regular expression or feed it the text that you're looking at, and it will help you with a regular expression. Then you can verify and validate that regular expression using regex 101. Fantastic tool. The anchor is also what's necessary. So this is a regular expression I've just come up with and tested on regex 101, and then I've dropped that into, I've dropped that into the rule here. So we're saying, stupid text boxes that are wrapping. There we go. So if opmantic MIB event, and then it matches some words, and then there's a space, and then there's the words opmantic MIB, and then there's the words detail, then there's this pattern, and then there's the words opmantic, and this anchors the text and finds those matches and is non-greedy, so it will find the right things and just extract out the variables that we're interested in. and that will now we capture event and details. So again, this is the essence of how we do, how we're doing the rules. If this pattern is true, then capture these things, or then set these properties. That's what we're trying to do with these events. And I just gave an example here. So this is an OID when it's unparsed, and this is an OID when the MIBs are all loaded and everything is looking good. And why I wanted to just explain this is you don't need to load the MIBs at all. If you're happy typing in OIDs and matching on OIDs and doing that, you don't need to load the MIBs at all. You can just use the OIDs, and some people do that. I've seen many people in many systems just use OIDs instead of using the named MIBs. I don't mind OIDs, I don't mind IP addresses. I just find DNS names easier than remembering all those IP addresses. And I find MIBs easier than remembering MIB names, and variable names makes more sense to me than remembering OID numbers and so forth. So, loading the MIBs and getting the MIBs to resolve is a useful exercise to happen. So we finished, I thought we're about running to about time. I'm going to stop the recording now so that we can ask any questions of people who might like to ask any questions. But that concludes the training session, and now we'll open up for questions to the audience present.